Okay, hello. This one's a bit of a doozy, so I'm going to talk fast so I don't waste time. Okay. So we've got a block that's swinging. It's going in a circle. We got some tension here. When in doubt, start with a free body diagram. If you tried to solve this by yourself, and you're in that moment where you're just like panic reading your formula sheet, and you're like, which formula do I use? Put the formula sheet away. All right, you're not ready for the formula sheet yet. Start with a free body diagram. Always, always. So we've got gravity down, and we've got tension going up the string. Force of tension. So part of that tension is going in. I'm going to call that FTX because it's like on the x-axis. And part of that tension is going straight up. I'm going to call it FTY because it's going like up and down. Okay. Couple thoughts here. So the sum of the forces in the y direction, we've got force of the tension in the y direction minus Fg. That equals ma. F equals ma always. But let's think about this. So we've got our object and we're like swinging it in a circle. It's not floating up or sinking down. Neither of those forces is winning. So they should be perfectly in balance. So we're actually not accelerating going up or down. So these forces should equal each other. So that acceleration is 0, which means we can add this. So Fty should equal Fg. All right. You might think I need to find the speed. Where's the speed? Hold your horses. This is a little Sudoku puzzle. We got to find all the pieces first. Okay. So Fty is what equals Fg. That doesn't help us find tension. And we need tension to find the speed. So let's find out what this is in terms of T. So we have our little triangle here. We've got the tension force. We've got Ftx. And we've got Fty. We have a right angle here. Okay, so we're splitting this tension force into its components. That's why y'all did vectors in Unit 1 to practice like splitting things into components. But if you're still like not awesome at it, that's okay. We're practicing, we're learning. You've been doing this for like what, a week? Summer school's crazy fast. Okay, so no worries. Hopefully you can get to the point where you can be like, oh, that equals Ft cosine theta. If you're not there yet, that's okay. All right, sometimes I have to draw it out too. But you're gonna look at this and go, well, the cosine of theta equals adjacent over hypotenuse because so ka toa adjacent hypotenuse. Okay, so the cosine of theta equals adjacent is Fty and the hypotenuse is Ft. Why am I whispering? I don't know. But Ft times cosine theta equals Fty. Okay, cool. So that does equals Ft cosine theta. Just making sure. Okay, so here we can put Ft cosine theta equals Fg. You know what? Let's turn this into a number. Okay, so Ft equals Fg over cosine theta. So that's mg divided by cosine theta. That's 0.05 times 9.8 divided by cosine of 36.9. So 0.05 times 9.8 divided by the cosine of 36.9. 0.799? I feel like that's not right. Okay, just a second. Okay, I double checked my math. That's not right. Okay, so we do 0.05 times 9.8 divided by the cosine of 36.9. You should get 0.613. Okay. And that's newtons. And you might think, that's not the speed, I don't care. Well, calm down, calm down. Okay, so that's the sum of the forces in the y direction. You might think, well, bummer, we didn't get anything useful. I don't know the speed. We'll need that tension later. Don't you worry. So now let's do the sum of the forces in the x direction. Okay, so in the x direction, we just have Ftx. That's what is causing our centripetal force. That's what's keeping us in the circle. The tension from the rope is what's keeping us in the circle. Okay, and that equals ma. And that a, that's a special a, that's centripetal acceleration. Okay, that equals v squared over r. Okay, so ftx, on which we can look at this triangle and know that that is ft sine theta equals m, and then instead of a, put v squared over r. Okay, so we're looking for v, so let's rearrange this. So r times ft sine theta divided by m, that equals v squared, but we want v, so we take the square root of that. That's what equals v. Okay, we are almost ready. We know ft equals that number, sine of theta, we have the theta, mass they gave us, we don't have the r. And it's going to be tempting to say the radius is 2. No, it's not. Okay, let's draw a little triangle. Should I move my face? There you go. Whoa. I will always do that. It will always be done. Okay. So we got our 2-meter rope. This is our radius. This angle is theta. You might think, isn't the diameter? And we need no. Okay, that's our circle. This is the center of the circle. So yeah, just that leg of the triangle, that's our radius. It is opposite theta. So sine theta equals opposite over hypotenuse. So 2 sine theta is our radius. So the sine of, let's just get a number. So 2 times the sine of 36.9 equals our radius, which is something. Nope. I type too fast. I get nervous. Y'all are going to be bored watching me type things. Okay, that's 1.2. So now we can put stuff in here. So we have 1.2 is our radius. Tension is 0.613. Sine of that is some number. The mass is also some number. We take the square root of all that, and that's our V. Okay, so let's do that. So times 0.613. Don't forget to square root. 2.97. Okay, I got 2.97 meters per second. That is closer to 3 than it is to anything else. That was a lot. We did it. Okay, if you didn't nail it the first time, that's okay. Okay. Try it again. Print out the problem again, or erase your dry erase board, or hose down your sidewalk with your sidewalk chalk, however you're doing this. Start fresh, do it again. Okay. That's the way. Maybe start with this big ol' equation. I think next time I do this, I'm going to start with this big ol' equation. Ooh, I thought that was a highlighter. Start with this big ol' equation. Okay, never mind. Start with this equation here. And then realize what pieces you need and like go off on a scavenger hunt and find those pieces. That might be a better way. I don't know. Whatever works for you. But yes, if you didn't nail it, try again. That's the way.